Well, that was some weekend, a long weekend. We're back, and now tomorrow we have the next day off, and then it's June. I mean, come on, what is going on around here? It's almost time for the Regents. So today we're going to review ATP, cellular respiration, and all that jazz. What happens in the mitochondrion? Da 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 do 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 da 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 do do. All right. Da 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 do do do. Hey now. Da 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 do do. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. ATP is an energy molecule. ATP, it's the fuel of it's like a battery, right? And then what happens is there's chemical bonds. When you break one of the phosphates off of ATP, it releases energy that runs life processes. Okay, that's ATP. How do you get ATP? Well, you have to generate it. You have to stick phosphates onto ADP, which is adenosine diphosphate, and you do that by doing something called cellular respiration. Right, ATP generation happens in the mitochondrion, right, the powerhouse of the cell. What the mitochondrion does is take glucose molecules and can break the bonds of glucose and use that energy to put phosphates onto ATP molecules. And basically, these guys recharge batteries. The waste product of that, of course, is carbon dioxide and water. And mitochondria can do this either with or without oxygen. Oxygen, though, makes it super efficient. Here's how I kind of look at it. Mitochondria gets glucose. Glucose is like a check, right? Mitochondria cash that check into usable cash, money, ATP, right? And it can do it two ways. It can either give you a little bit of money right now, or if you take your time and use oxygen, you can get a lot of money, a lot more money, like 18 times more money, right? So that's what happens in the mitochondria. We call, when you cash those checks right away, what's called fermentation or anaerobic respiration. When you wait and use oxygen to cash those checks, you take a little longer, that's called aerobic respiration. It's funny, before the break, we did photosynthesis. Respiration is just photosynthesis in reverse, right? In photosynthesis, you took carbon dioxide and water and used energy to make sugar, make glucose. In cellular respiration, you take glucose and oxygen and you convert that into usable energy, ATP, and the waste products are carbon dioxide and water, which can then be used by plants to make more glucose, right? They're complementary reactions, photosynthesis and respiration. If you remember, but cellular respiration happens in 3 steps. First step is called glycolysis. Glycolysis happens actually in the cytoplasm, and that's an anaerobic process that makes 2 ATPs, right? And then Krebs cycle, which is aerobic, that makes a few more ATPs. But if you can go all the way aerobically through what's called the ETC or electron transport chain, that makes a tremendous amount of ATP, right? Krebs cycle and the ETC happen in mitochondria. For you on the Regents, they won't ask you about the Krebs cycle. They won't. When you get to AP bio, you'll have to have like this whole, all these steps memorized. But most of you probably won't do AP bio. And those that do, you'll do it then. All right, so Krebs cycle, as long as you know the Krebs cycle has to do with respiration, that's all you need to know. And likewise for the Regents, you don't need to know the steps of the electron transport chain. You just need to know that if you do respiration without oxygen, you make very small amounts of ATP, and that's called fermentation or anaerobic respiration. If you go into the mitochondria and you use oxygen and you do the Krebs cycle and the electron transport chain, make huge amounts of ATP, huge amounts. It's extremely efficient, right? So most organisms choose to go aerobic, right? We can do both, but we choose more often to be aerobic. It's just way more efficient. It's more bang for the buck, so to speak. Now, I would be remiss if I didn't mention that if you do fermentation, if you go with no oxygen, you get extra waste products in addition to carbon dioxide and water. And it depends where you are. In muscle cells, the extra waste product is called lactic acid. Lactic acid changes the pH around the muscles, and when the pH around the muscles drops, it starts to denature proteins, and the muscles stop working. That's what causes cramping. Okay? And then some bacteria and yeast, they'll turn it into ethyl alcohol. Ethyl alcohol is a waste product. And that's how beer and liquor and wine and stuff are made, is you take yeast and you feed them sugars, but you don't let them have any oxygen. They wind up poisoning themselves with alcohol. You collect that alcohol and you put it in a bottle and then you sell it. People have been doing that for 15,000 years, no secret there. But those are extra waste products of fermentation. Of course, the mitochondria, and once again, is the powerhouse of the cell. Mitochondrion is singular, mitochondria is plural. And remember, mitochondria has its own DNA. So mitochondria copy themselves. We learned you get all of your mitochondria from your mother, right? And so if you have good mitochondria, you can thank mom for that. And then, of course, if you stress mitochondria out, they tend to copy themselves, make themselves bigger and copy themselves. That's what training does. That's what getting in shape does, is you've got to stress out your mitochondria and then let them give them time to respond, to copy themselves. And then the next time you try to stress them out, they can handle it more and more and more and more. That's why you can keep training and training and training and get better and better and better. All right? So, yeah, use your mitochondria to do the rest of the class today.